Okay, so for 23, we just need to evaluate the function defined by f of x equals 3x squared minus 4x plus 2. So f of negative 3, well, we see how we have x here, and now we have negative 3. That means we're going to put negative 3 in for all our x's. So 3 minus 3 squared minus 4 times minus 3 plus 2. That's going to become 3, negative 3 squared is 9. Minus 4 times minus 3 becomes a plus 12 plus 2. So it's going to give us 27 plus 12 plus 2, which will be 41. For our next one, f of 0, we're going to plug 0 in for our x's. So 3 times 0 squared minus 4 times 0 plus 2. Well, the first two things just become 0. So we're just going to get 2. And for f of 2, we're just going to plug 2 in. So it's going to be 3 times 4 minus 8 plus 2. 3 times 4 is 12. So 12 minus 8 plus 2, it's going to be 4 plus 2, which is 6. Going on to the next one, we need to find the domain of each function in interval notation. Well, we have two main restrictions. Inside of a square root can't be negative, and we can't divide by 0. So in this case, we have an x on the bottom of the fraction. So I'm going to say 3x minus 7 cannot equal 0. So it means that 3x cannot equal 7. It means x cannot equal 7/3. So our domain is going to be everything except 7/3. So negative infinity, comma, 7/3, union, 7/3 to infinity. Literally everything except we're going to skip over 7/3 because we're not including them on either side. For square roots, we need the inside of a square root cannot be negative. So it means that x minus 6 has to be greater than or equal to 0. So x has to be greater than or equal to 6. So our domain is everything bigger than or equal to 6. So 6, comma, infinity. And that is our domain. The next one, well, there's no x's on the bottom of a fraction. There's no square roots, so it's just going to be all real numbers. There is no restrictions. Last one, there's x on the bottom, so we need to try to factor that to figure out when that equals 0. It says x plus 5x minus 3. So that means x cannot be minus 5 or 3, because either of those make that 0. So now we make our interval. It's negative infinity all the way up to minus 5. Can't include that. Minus 5 to 3. Don't forget about the middle part. And 3 to infinity. And then we're done. Going to the next one, determine the slope of the line passing through the points. Well, your slope is y2 minus y1 over x2 minus x1. If you don't have that memorized, make sure you put that on your note card. We have x1, y1, x2, y2. So minus 6 minus 4 over minus 1 minus 9, which is going to be the same thing as minus 6 minus 4 over minus 1 plus 9, which is going to give us negative 10 over 8, which is, we can simplify that into minus 5 over 4. That's our slope. Keep going, find the equation of the line in slope-intercept form. That is y equals mx plus b. The passes through the points 7, negative 3, and 4, comma 1. Well, to find our slope, we're going to use the same equation before. So it's going to be y2, which is 1, minus y1, which is negative 3, over x2, which is 4, minus x1, which is 7. So it would be 1 plus 3 over, that should be negative 3. So we get 4 over minus 3. Okay, so that means it's going to be minus 4/3 x plus b. But we need to figure out what the b value is. One way we can do that is we can plug in one of our points. I'm going to pick 4, 1. You could do 7, negative 3. It's the same thing. So our y value there is then 1 equals minus 4 over 3 times 4 plus b. Minus 4 over 3 times 4 is the same thing as minus 16 over 3. If I add the 16 over 3 to the other side, I get 1 plus 16 over 3. In order to add fractions, then you need a common denominator. So 1 is the same thing as 3 over 3. 3 divided by 3 is 1. 16 plus 3 is going to be 19 over 3 is our b. So our equation is going to be, I'll just go back here and erase this right there. Y equals minus 4/3 x plus 19 over 3. And that's our final answer. Okay, determine the average rate of change of the function of the following intervals. Well, when it gives us these intervals, it's important to note that these are all x values. So this is x1 and this is x2. And your average rate of change is just, it's basically the slope equation. It's f of x2 minus f of x1, which these are the same thing as y2 and y1. Those are just different ways to write the same thing, over x2 minus x1. So I'll say this is going to be f of 1 minus f of 0 over 1 minus 0. F of 1, if we plug 1 into that, well, it's going to be 2 times 1 squared, which is just 2, because 1 squared is 1, and 2 times 1 is 1. It's 2, sorry, plus 2, it's 4. If we plug in 0, well, 2 times 0 squared is 0, plus 2, it just gives us 2. So it's going to be 4 minus 2 over 1 minus 0, same thing as 2 over 1, which is just 2. That's the average rate of change from 0 to 1. Going on to part B, again, it's going to be, I'll say this is x1, that's x2. It's going to be f of x2 minus f of x1 over x2 minus x1. So it's going to be f of 3 minus f of 1 over 3 minus 1. Well, f of 3, we can plug 3 in. So 2 times 3 squared plus 2 is the same as 2 times 9 plus 2. That's 18 plus 2, which is 20. F of 1, well, we figured that out earlier. That's 4 over 3 minus 1. So that's giving us 16 over 2, which is 8. Finally, again, x1, x2. I'm going to go off on the left side to do this one. So it's going to be f of 0 minus f of negative 2 over 0 minus minus 2. Well, that's going to become 0 plus 2. In f of negative 2, that's going to be 2 times minus 2 squared plus 2. Minus 2 squared is 4, so 2 times 4 plus 2, which is going to be 8 plus 2 is 10. So it's going to be f of 0, we figured out earlier, was 2, minus 10 over 2. So negative 8 over 2, which is going to give us minus 4 for part C. I'll go ahead and I'll rewrite this to be a little bit more visible, like what the answers are. But that's all we have to do. F of x2 minus f of x1 over x2 minus x1. If you have a hard time remembering that, I'd probably put that on your note card. Question number 28, it says write an equation of the line in slope-intercept form that passes the point 5, 4 and is parallel to the line x minus 2y equals 7. Then write the equation in slope-intercept form of one that is perpendicular going through the same point. So parallel lines are going to have the same slope. So let's write this in, let's solve this one for y, and we can figure out what our slope is. So x minus 2y equals 7. So that means minus 2y equals negative x plus 7. Divide everything by negative 2. It's going to be 1/2 x minus 7 over 2. So when we make our parallel line, we're going to keep that same slope, but we're going to have a different point that we're going to go through, a different y-intercept. To figure out what that y-intercept is, we can use our point 5, 4. So 4 is going to be 1/2 times 5 plus b. Well, that's going to be, I'll just write it as 5 over 2 plus b. So 4 minus 5 over 2 is going to equal b. 4 is the same thing. If I multiply it time, treat that as 4 over 1, multiply it by 2 over 2. It's going to be 8 over 2 minus 5 over 2, which is 3/2. And that's our b value. So for the first part, I'll say over here parallel. Gotta remember how to spell parallel. It's y equals 1/2 x plus 3/2. Now I'm gonna erase this part where I actually solve for the parallel, for what the b was for the parallel, and I'm gonna go ahead and I'll start on the perpendicular one. So we're going to do the same thing. We're going to need this y equation. But when we do perpendicular, our new slope is going to be our old slope flipped over, and we change the sign. So it's going to be -2. So y equals -2x plus b. And we use a 0.54 again. So 4 equals -2 times 5 plus b. So 4 equals -10 plus b. So that means 14 equals b. So our perpendicular is going to be y equals -2x plus 14. And that's it for that one. Okay, looking at this one, it wants us to solve the system of equations, which give that equations using the substitution method. So substitution, we're going to solve for one variable and plug in the other. So I'll take our first equation. I'll solve for x. So x is 5 minus 3y. And you can solve for either variable in either equation. Once we solve for x in the other equation, we're going to plug that in. So 5 minus 3y minus 2y equals -18. Distribute that. 15 minus 9y minus 11y equals -18. I can subtract the 15 over, or sorry, not put minus 11y. I was thinking too far ahead. 18, I can subtract the 15 over, so, and I'll combine these. That becomes minus 11y equals -33. So y is 3. Well, now that we know what y is, we can solve for x. But we know x is 5 minus 3y, so I'll plug it into here. X is 5 minus 3 times 3, which is 5. X is 5 minus 9, so x is -4. And that is going to be our solution. We're going to say our solution is -4, 3. Moving on to the next one, it wants us to use addition / elimination. So when I do this, I'm going to write out both equations, but I'm going to multiply this whole equation by -2. So everything will be multiplied by -2. So it'll be -6x plus 14y equals -2. The other one I'll just copy down. -17. And whenever I add these together, -6x plus 6x those cancel. We get 19y equals -19. So y equals -1. Now I can plug that into either equation. I'll plug into the second one just because that's the one I chose. No, like real good, either one is going to work. So we get 6x minus 5 equals -17. 6x equals -12. X equals -2. So our answer is -2, -1. Okay, going to this next one. It gives us the data of enrollment in a college X years since year 2000. So years since 2000 is important to know. First, we use our graph calculator to find the least squares regression line. So you can't really, unfortunately, I can't show you me doing this, but if you press on the TI-83 plus stat and then edit, you can put in your lists. And then from there, if you go to stat again, you press the right arrow to go to calc. You can go down to lin reg. You press enter, and it'll give you all your information. If you don't have your R squared or your R, which we're going to need for the next part, press second 0, that's your catalog, and scroll down until you see something that says diagnostics on. Enter, and then enter that, and then try it again, and it should give you your R squared value and your R, because we will do that. So use our graph to find our least squares regression line. So round to the nearest tenth. So what I got is y equals 369.6x plus 22,110.7. Okay. From there, we're going to use our R value to determine, that's our correlation coefficient, so R, not R squared. And my R value here is 0.9977. And generally, if it's close to 1 or -1, either one, we're going to say it's good. And when I say close, really anything above 0.7 or below -0.7, -0.8 or 0.9, we're going to say those are all good. On an exam, it's going to be pretty obvious if it's good or not. If it's close to 1 or -1, it's good. So it's good. And so next we need to try to predict our enrollment in 2022. Now note, X is years since 2000. So in this case, 2022 is 22 years since 2000. And I can go ahead and plug that in to my calculator. I'll just plug 22 in for X here. And what I get is 30,241.9, which you could say maybe 3,242 or 3,241 because you can't have like 0.9 of a student. But generally, like we're probably going to round up, so we'll say it's going to be 30,242. That's our final answer. Okay, so this next one was to solve the system of equations, but this is nonlinear, so we're going to do, it's going to be a little bit different than the previous ones. What I'm going to do is I'm going to pick one equation. I will go with the bottom one, and I'm going to solve that for x. So 2xy plus y squared equals -5. 2xy equals -5 minus y squared. Divide both sides by 2y. We're going to get x equals -5 minus y squared over 2y. Okay, now that I have that, in my other equation, I'm going to plug that in for y. So it's going to be 4. Sorry, not for y, for x. 4. Instead of x, I'll put -5 minus y squared over 2y times y plus 3y squared equals -9. This y can cancel out that y down there, and this 4 and those 2 can make this into just a 2, which I can then distribute. So I'll get -10 minus 2y squared plus 3y squared equals -9. Minus 2y squared plus 3y squared is just a single y squared. -9, add 10 to both sides, y squared equals 1. So y is going to equal, don't forget your plus or minus square root of 1, which is 1. And so we need to find the corresponding x's for each of these. So if y is 1, well, we know that x is -5. I can plug into our equation we found for x earlier. -1 squared over 2 times 1. Well, -5 minus 1 is -6 over 2, which is -3. Okay, well, what if y is -1? Well, it's going to be x is going to be -5 minus -1 squared over 2 times -1. Well, -1 squared is just 1. -5 minus 1 is so -6 over -2, which is going to be +3. So my system, my solutions are going to be -3, comma 1, because those for y equals 1, I found x was -3, and 3, -1. And those are my answers. Now going on to the next one, we're going to use a system of equations to solve the following. Electronic sign for grocery stores in the shape of a rectangle. So I'll quickly, draw a little rectangle. I'm going to work down here. Okay. The perimeter of the sign is 72 feet and the area is 32. Find the length and the width. So I'll say this is my width and that's my length. Well, the perimeter is I add those up, so 2w plus 2l, and we know that equals 72. And the area, which is w times l, is 320. So what I'm going to do is I'm going to go on this equation and I'll solve for either l or w. I'll solve for w. So I'll say 2w equals 72 minus 2l, divide everything by 2, 36 minus l. Then I'm going to plug that in here. So w times, plug it in for that one. So 36 minus l times l equals 320. Distribute my l, so 36l minus l squared equals 320. I'll add my l squared over and subtract my 36l, so 0 is l squared minus 36l plus 320. From there, I can do quadratic formula, but this is going to factor to L minus 16, L minus 20. And so I can get either L equals 16 or L equals 20. Well, if L equals 20, I can plug these into this equation up here. Or to find the width, I can just use that one instead. So it means the W would be 36 minus 16, which is 20. And here the W would be 36 minus 20, which would be 16. So you see, either way, it's 16 by 20. The question is it wider than tall, or is it like that? Like which, that wasn't a good drawing. Like that. Is it like, which way is it oriented? But either way, the dimensions are 16 feet by 20 feet. And on an exam, like, make sure you answer that in like a sentence, because the question was in the form of a sentence, so you got to answer it in the form of a sentence for word problems. Okay. So going on to number 34, it says, given the basic function f of x equals square root of x, give the transformations that would yield the function 2 times the square root of x minus 5 minus 3. Well, the first thing we need to look at for transformations are horizontal shifts. And horizontal stuff is on the inside, and the inside, I'll say, is inside the square root, right? So on the inside, a shift would be a plus or a minus. Am I adding or subtracting anything? Well, I'm subtracting 5, so I'm going to have a horizontal shift. But the thing about stuff on the inside that goes like horizontally is always opposite what you think. So subtracting 5 is going to shift right 5. I don't have anything else like horizontally, but vertically, I see I have this. We're going to go, we do stretches before, we do our stretches before our shifts. So I'm going to look at this 2, and then we'll look at the 3. So a 2 multiplied on something, that's a stretch. Vertical acts normal, so you see multiply by 2, we're just going to stretch it by a factor of 2. That's just going to be straightforward because it's vertical stuff, so. And then lastly, we have this minus 3, so that's going to be just a shift down 3. And that's it. Those are all our transformations. On number 35, we're given this piecewise function. We evaluate the following: n of 0. Well, 0 here, this is normally n of x, so 0 is my x value. So the first thing I look at is I look on this right side. X is 0 falls into which of these criteria? Is it between minus 3 and negative 1? No. Is it between minus 1 and 2? Yes. So what is it? It's just what x. So if my x value is 0, because it falls under this criteria, then whatever my x value is, that's just my answer. So this one is just 0. Let's go to the next one. N of negative 2. So which of these criteria does negative 2 fall under? Well, it's between minus 3 and minus 1. So my answer is just minus 4. N of 2. Well, going through that, it falls under this last one because it's greater than or equal to 2. So it's going to be minus 2 squared plus 4. Well, 2 squared is 4, so minus 4 plus 4, which is 0. And now n of 5. Well, n of 5, that's also going to be this last one. So I'll do minus 5 squared plus 4. It's going to be minus 25 plus 4, which is minus 21. And those are our answers. So next up, we're going to determine the relative minima and maxima of the following. Well, a minima or maxima is going to kind of be like our peaks or valleys, right? The idea is right here, it's a maxima because if I go to the left of it or right of it, I'm below. And here's a minimum because I go to the left or the right, I'm above. So I see a minimum here, and a maximum there. So I'll say I have a min of negative 4 because that's my y value. And we're going to say it's at our x value, so that's x equals minus 2. And I'll list that's this first one right here. I'll list this one next. So min of -4 at x is now going to be +2. And finally, I'll say, I'll go under, I guess. We also have a max. It's 0. That's our y value there at x equals 0. For this next one, well, I only see one peak, so I'll say we have a max of 2. And what x does that occur at? -1. Or x equals, x equals -1. Okay, now we can move on to the next one. Use interval notation to write the intervals for which the function is increasing, decreasing, or constant. So, first off, just kind of look left to right. Starting at -3, our intervals will be all x values. Well, I can tell that we're decreasing until -2. So I'll say, I'll start my decreasing list. I can add on to this if I need to. If it's like there's a second decreasing section, though. In this case, there isn't. -3 to -2. I'm using parentheses because right here, this -3 isn't included. And right there, it like changes. So there's that weird hard break, in which case, at -2, are you decreasing or are you constant? It's kind of unclear. So we're just not going to include it. Okay, well then from -2 to 2, it's just a flat line. So we're going to say it's constant. And again, I'm going to use parentheses, not brackets. Because at those spots, they're changing, and that's kind of unclear. And then finally, increase from 2 to on. This arrow says it's going to infinity. We're just going to say it's increasing for the rest. Okay, now for question 38. Given the functions f of x and g of x, find the following. So first one is to f plus g of 3. This is the same thing of f of 3 plus g of 3. So f of 3, so plus, not a times. If I plug 3 into that, 2 times 3 is 6. G of 3, I plug 3 in here. 3 times 3 is 9, plus 10. Plus 1 is 10. So just add those together, I get 16. Going to the next one is g minus f of -2, which is the same thing as g of -2 minus f of -2. Well, if I plug -2 in for here, 3 times -2 plus 1, well, that's -6 plus 1, so it's -5. Minus, if I plug -2 in here, 2 times -2 is -4, so -4, so -5 plus 4, so -1. For this next one, I'll say this thing is g of 4 times f of 4 times g of 4. Well, f of 4, I plug 4 in. 2 times 4 is 8. G of 4, 4 times 3 is 12, plus 1 is 13. So 8 times 13, that is 104. And then this same thing is f of -1 divided by g of -1. Well, f of -1, if I plug -1 in, you get -2. If I plug -1 in for g of x, you get -3 plus 1, which is also -2. -2 divided by -2 is +1. And that is that for that part.